talk about lake effect a lot here locally, and one of the factors that really influence our winter snowfall totals. And tonight we do want to dig just a little bit deeper into lake effect snow and how it impacts our region, and take a quick look. It's not a real deep look, but a little bit deeper than what you would typically hear about on why lake effect forms here across our region. One of the things that we watch as meteorologists, we have to watch the air above the ground. And as we get deeper into the fall season and toward the winter season, we start looking at these temperatures 4, 5, 6,000 feet up in the air. And what we're watching for is an actual temperature difference between what this air temperature is several thousand feet off the ground and what the air temperature is on the water, basically the lake water temperature. And late this week here, as we put this together this evening, you can see what those water temperatures are across the Great Lakes. In fact, Lake Erie currently sitting, and you'll notice out to the west there, water temps are in the low 50s already, mid 50s in the deeper part of the lake there. So the deeper the water, it takes a little bit longer for that cooling to take shape into the season. But what we're looking for is the difference between this lake water temperature and the air temperature above it. And now, of course, as Craig talked about, you need wind to blow in across the lakes, and that brings in, of course, the colder temperatures from the north. Now, that needs to be roughly 10 to 20 miles per hour, give or take a little, because you actually need some wind to help pick up this heat and moisture, this little boundary that develops on the water from this temperature differential, and kind of get it mixing up into the air. Too strong of a wind would actually tear this apart. So there's a real fine line in here to get lake effect going. But 10 to 20 is kind of the magic number when we're talking about wind speed across the water. And as that flows across and picks up this moisture, it's all about convection. So basically, colder air above warmer helps that air parcel grow and go upward in the atmosphere. So that difference, I was talking about the lake surface temperature versus the actual air temperature. 23 degrees is the magic number. So that's a 23-degree colder temperature of the surface of the water that the air needs to be several thousand feet in the atmosphere. It's kind of our magic number. The colder that temperature is, if that's 30 degrees colder or 40 degrees colder, that just tells us that there is going to be actually stronger lift in the atmosphere. So lake effect could get bigger and stronger the colder that temperature gets. And that helps, of course, bring that moisture upward with that convection and lifts up into these clouds across the Great Lakes. So really, when it comes to forecasting lake effect, we're looking for, number one, the difference in the air temperature versus the water temperature, and that changes through the season. It's a moving condition as the water temp is always changing as well as the air temperature, but we're looking for that threshold, and that helps to develop the clouds. Of course, we're watching the wind speed. We're also watching the wind direction because too much shear, too much change in wind speed and direction can actually tear these clouds apart in these bands, and that also helps, of course, push this back over land across into northeastern Ohio and northwestern Pennsylvania. And that's where we get our heavier snowfall. So there are multiple factors, Craig, that we're looking at here as we get into lake effect. Of course, we watch for temperature, we watch for wind speed and wind direction, and we don't want too much shear because it can tear those things apart. So some of the little tips that we deal with, Greg.
Yeah, of course, it makes our job a lot more interesting when you're trying to figure out where those are trying to set up. A lot of people are very concerned in that lake effect time, and a lot of times it's quite hard to feel exactly where those bands are going to set up because it's very localized. So as we take a look at some of the little more terminology of what we're talking about when we're talking about these areas where these do traditionally set up, we have the snow belt, of course, which is the area where you get more of that snow because of the lake effect. And we have the primary and the secondary. The primary is what you see in pink. That is about I-80 and north, where the secondary snow belt goes to around the Columbiana-Mahoning County line. The northern snow belt, then we kind of take that primary and shift it a little bit and talk about that from a northern and southern perspective, just because a lot more often than not, that northern snowbelt gets a little bit more than the southern snowbelt does, just to kind of depending on exactly where those fetches are located. And of course, you can see that kind of takes us through about halfway through Trumbull and Mercer counties.
Yeah, Craig, and the magic word you said there was fetch. And I talked about that wind speed that we deal with coming across the lake. It all depends whether it's kind of crossing straight across the lake from north to south or going from the northwest to the southeast. And that fetch makes a big difference in the intensity of the snow sometimes, as well as where the heaviest falls. And you talked about the primary, the northern snow belt. That we typically get the heaviest snow up into Ashtabula, Crawford County, northern Trumbull, and Mercer County when you get that west fetch. That's across the lake. Now, if we shift that wind to the north, it helps that snowpath, those lake effect bands, actually drop their way southward, and that pushes that into the secondary snow belt. Now, the one hiccup with this is this kind of a fetch, when we come out of the north, it can and it will actually at times connect to Lake Huron, and in turn, that connection can really dump some heavy snow. We experienced some of that this past week with those heavier snowfall totals. So